like to welcome you to today's session. This is a source defense webinar over PCI DSS compliance and specifically what our experience has been seeing folks who build their own in-house solutions and what a solution should look like and some pitfalls to avoid when you are considering making your own. Source Defense is a company that has been in this space for a very long time. We were founded about 10 years ago, specifically to develop technology to defeat eSkimming attacks, to prevent them from doing damage to websites and the visitors who interact with them and the companies that serve them. My name is Matt McGurk. I'm our head of field engineering here. I'll turn on my camera so you guys can see me for a second. Hi, my name is Matt McGurk. I'm our head of field engineering. I've been here for 8 years. I have a background in web application development and have spent a lot of time talking about the PCI DSS requirements related to eSkimming security over the last 3 years or so. I'm happy to be able to present this today. I also have a lot of personal experience working with our customers, understanding the projects that maybe they attempted before they came to Source Defense and just seeing what a self-developed solution might look like. So happy to be able to share. In terms of format and an agenda, if anyone would like to ask questions, feel free to do so. I will be keeping an eye on the Q&A function here in Zoom. And I'll try to handle those as we go or towards the end, depending on what the content of the question is. Like I said, the agenda, I kind of have this structured in 3 segments and 3 acts, if you will. Basically, what is a compliant eSkimming solution? And then talk a little bit about content security policy and sub-resource integrity. So these are the main things that one might use if they were going to build their own in-house solution. And then last, what is a usable eSkimming solution? So I want to develop this idea of, you can approach this from the point of, how do I satisfy these requirements to the letter of the law? And maybe how do I do that with the resources I have within my organization? How do I make something compliant versus how do I make something that's actually usable? Like, how do I get a solution on board at my organization that's going to work with my team and my tech stack and overall operations and not be a burden and not, even if it looks like from the outside a cheap way to do it, what are the actual costs and total cost of ownership of an in-house solution? So compliance versus usefulness or practicality is kind of the theme here. So we're going to start by talking about content security. Well, actually, I'm going to start with the idea of how does one approach making a compliant solution? By compliant, I mean, you want to satisfy these requirements. You want to be able to say to your assessor or as part of your self-attestation questionnaire, or et cetera, you want to be able to say, the thing I came up with checks these boxes. So how do you do that? What you need to do that is a handful of different things. What you're seeing on your screen right now, and we'll drop the URL for it into the chat, also the QR code on the bottom right. This is an excerpt, this is a table from something published by the PCI Security Council in February or March of this year. It's called the E-commerce Guidance Supplement for DSS requirements 643 and 1161. So the requirements themselves live in the DSS, the data security standard, which is a different document. The e-commerce guidance document then is meant to provide a lot more explanation. I think it's about 30 pages of the concepts behind the requirements, some ways you can approach them, and et cetera. I'd recommend anyone who's interested in this space take a look at that. And I used the word e-commerce a couple of times. I helped write parts of it and amongst a lot of other people, but I think the e-commerce thing got dropped along the way, and now it's just a guidance document. So if you're a payment service provider or you're not selling goods or services on your site, but you still process credit cards, it's a useful document. What I'm showing you on here is one table. I think it's on page 17, and it basically breaks down the requirements. Like you can see on the left, the elements of the requirements, and then the controls help meet those elements. So the idea here was that, if you read the standard itself, it kind of says you can use CSP and SRI, content security policy and sub-resource integrity, or you can use a third-party script management system to satisfy these requirements. So what the goal of this document, the authors of this document wanted to explain how you would use different techniques to actually meet the requirements, rather than just say like CSP and SRI or a vendor solution will do it. How do those controls actually apply to the different parts of the requirements? Because, as we'll go into in some length, CSP isn't just like, you don't just like install it and then everything's done and you're compliant. It's a tool like anything else that is meant to apply to do certain things, and those things might satisfy one or more of these requirements or not. So for instance, just as an example, when you look at, let's say, the inventory or the alerting part of CSP, like so right here, when we say CSP can be used as part of an inventory process, that's true after a fashion. Like you can get reports out of the browser sort of about what scripts are there, but CSP isn't going to just tell you what's on all of your web pages. It's not an inventory tool. You could use it in part to help with the inventory part of the requirements, but it's not just a turnkey kind of thing. And the same deal with most of these other individual controls. None of these on their own is just going to solve the problem. So when you look at either doing it in-house, your own team building something, or a vendor solution, you need to make sure the solution does these things, right? But you need to make sure that your own mixture or the vendor's own mixture of techniques satisfy those how you want. And so I'm just trying to get away from the idea of like, there is one way to do this. Either you internally need to solutionize and you can use some of these controls, or you need to expect a vendor to show up with a product that does all these things. Doesn't necessarily need to use all these technologies. You don't need to use any specific thing in here. It's just that the service or the product provided by the vendor needs to handle all this for you in a satisfactory way. So this table can be really useful. So as we get to the idea of what is a compliant solution, a compliant solution is one that satisfies all these things and then uses some combination of these techniques or their own techniques or something else to get the thing done. That's the like brass tacks to satisfy. I want to go into some more detail about those two technologies, content security policy and sub-resource integrity. The reason I wanted to go into these in specific is because, in my experience, when people read the data security standard, they see those two recommendations in that guidance, in that document, and they say, okay, cool, here's what we're going to do. We're going to spin up a project team, probably in application development. They're going to implement CSP and SRI, and we're going to be done with 6.4.3 and 11.6.1. We'll be good to go. That's challenging for a couple reasons. One, I think that it gives the way the guidance is written, it gives the idea that you can just turn these things on and then you're done, which is not really the case. And then two, it's not, in my opinion, and in the opinion, I think, of the security community in general, it doesn't actually stop an eSkimming attack. Like it'll still probably leave you open to a problem. So what I'll do here is talk about what these things actually are and how they work. And I'll give you an example of how they may not work for you. The basic idea behind CSP is that if you want to add something to your site, like a third-party chat tool, like a Google Analytics, even one of your own scripts, no matter what and just to frame this thing up, we're talking about web pages, we're talking about the JavaScript inside web pages, that code that makes everything interactive. We're talking about third and first-party JavaScript. Third-party stuff are integrations hosted on other servers, files coming from other parts of the internet into your web pages. First-party is stuff you write. So let's say you want to integrate a new third-party tool. What you need to do in a CSP approach is find a list of all of the third-party tools and all the files belonging to those third-party tools or your own first parties, and basically store that list in your web server, in your web application. This is a very simplistic explanation, but that's the idea. Come up with a list of URLs of your scripts, feed it into something that the web server knows about, and then the web browser, the server sends that out to the web browser, and the web browser is going to evaluate that list as the scripts are loading. So it's kind of like verifying your intent or something like that. It's enforcing an inventory amongst a few other things. And I'll get to that in a second, but this is the basic idea. Compile a list of all the code that's supposed to be there, tell the application about that code, and then tell the browser to enforce that list. A CSP policy is gonna, and there's a couple slides in here that get a little technical. I'll keep it pretty high level, and it's not essential that you absorb any of the ultra specifics here, but I thought it'd be useful to go in a little more depth on this webinar than we usually do. A CSP definition looks something like this. This is a very simple one, but the idea is where can the scripts inside the web page, where can they talk to? Where can they load frames from? Where can they load media from? And I think this second to last, this kind of larger list here, is the most relevant one from a DSS standpoint. Where can scripts be loaded from? So really, the first line here and the 13th line here are the most critical parts of a DSS CSP implementation. Where can code load from, and where can code talk to? This particular CSP says it can load from these handful of different parts of the internet, and that it can only talk to the web page itself. It's kind of a pretty restrictive policy. And what that means is basically, so this is explaining a little bit more about what I was talking about a moment ago, that at runtime, as the web page is loading, it'll evaluate that list and it will make sure that only the stuff is supposed to load as defined. The disadvantages of this are that trusted sources can still serve malicious content. CSP really isn't making any claims about the behavior of scripts. It's not attempting to control the behavior of scripts, except for a couple pretty high level things like where can the script talk to? It can't say, this script can draw an image or add a form. It can't control anything at a behavioral level. That's one of the biggest problems with CSP. You have to have a really complete list of the CSP, of the stuff you're going to add to the CSP. The inventory has to be compiled by you and upfront and maintained. And then anything can change at any given time. Web technologies are very fluid and very dynamic, meaning that if one of your third-party integrations changes or your dev team releases a new version of the app, maybe it uses, unique identifier, like it has hashes in the strings or something in the file names to organize the files. Basically, you got to stay really on top of any changes to the web application, whether you made them or your third parties made them. That's the main disadvantage. What I want to show you here is an example of a eSkimming attack and kind of how CSP would handle it. So these are pre-recorded videos. I'm going to narrate them as we go through here. But the basic idea is when an eSkimming attack occurs, a visitor will be going through their process of checking out and doing their business on an e-commerce site. There is, of course, a whole bunch of JavaScript that's in the background there. On this particular site, there is a malicious piece of code that's getting loaded into the browser. This example does not include any CSP. And so as we'll see here in a second, when the visitor enters their card number and completes their transaction, that the data can be communicated out of the browser and sent to another domain maliciously. This is kind of the most classic form of an eSkimming attack. There's a lot more variations on the theme and techniques and et cetera, but this is a very classic one of just invisibly skimming. So you can see here in our other browser tab, ihacker.me is the drop site where that information was collected, and the attacker has successfully stolen that customer information. If that website had CSP implemented, so we're going to see that same thing happen, but now with CSP in place. In fact, it's that CSP I showed you before. So these rules from a moment ago are now about to be enforced in that web session while the attack is happening. So we're going to see the same stuff get populated. We're just showing here that the CSP is in fact in place. CSP, by the way, is served through the headers of the web page. It's kind of the web server level. When you see this stuff in DSS about verifying headers, that's a big reason why, or really the only reason why. If you implement CSP via headers, you want to make sure it doesn't disappear without you knowing about it, is the idea there. So this is going to take place. The person will enter their card number, place an order, and you can see here the script halts, the page halts. And the reason that happened was because, let me change my options here and show my actual cursor. So the reason that happens is because, there we go. Sorry, I wanted the player controls here so I can show you a specific thing. So when the person hits submit, the script, the malicious script on the page, tries to connect to a suspicious or actually malicious domain, but basically a domain that's not in that CSP list. So it's a little small on the right-hand side of the screen. I apologize, but the browser is saying, I refuse to connect to ihacker.me because it violates the CSP directive. You can only connect to the web page, the web server itself. So the CSP did what it was supposed to do. It saw a script try to connect to a domain that's not in that list, and it thwarted it. Now, CSP can be very easily bypassed. And like I said, it's going to get a little technical, but don't worry. This is actually the worst one in the whole presentation, so we're going to get through it quick. This is an example of how a CSP bypass would work. And there's like dozens of techniques to do this, let alone actual kits out in the wild. This is just one way to do it. And it relies on the fact that in a CSP directive, you're going to have to load a bunch of stuff from insecure sources, or you're going to have to trust a lot of different sources. And in specific for this example, the kind of crux of this is that you're including frames. I'm looking at line 7 here. You're giving permission to the browser to load stuff from thirdparty.me, to interact with thirdparty.me. And this could be any third party. It could be Google Analytics. It could be something else. But the idea is that you're going to grant permission to a bunch of different stuff for your website to work. And if any of those are used either for exfiltration, so what I mean by that is the attack interacts with a legit domain, like it talks to Google Analytics and just posts data back to the attacker's own Google Analytics account, or certainly a compromised third-party domain, like in the case of a supply chain attack. It's very easy for the attacker to get around that. So the core idea here is you're going to have to make your CSP kind of leaky, kind of full holes, just for a modern contemporary website to work. So when we look at this, when we look at the attack in place, the attack now is that one we saw the code listing for before. And basically what that attack does is if the exfiltration fails, if the browser blocks the script data getting sent out, then the second part of the attack will spring into action. So we're seeing here, again, this is the CSPs in place, but the attack has been modified to overcome it. So our unwitting visitor here is going to enter their card number one more time. And for anyone who notices, that's a Princess Bride joke in there, the movie The Princess Bride, Inigo Montoya and Finger Street. Anyway, just this aside. So when the card number gets entered here and they're entering a new password too, you'll see the same thing happen where the error message gets thrown and the CSP is in effect, but because that CSP also allowed connections to another domain, to thirdparty.me, the attacker just posted it there, grabbed it from there, and then dropped it to the drop site as well. So I know that if you're not super into JavaScript or reading that on the fly, it may not be obvious, but the basic idea is because this CSP directive required loading from a different domain. Like I said, it could be Google Analytics, where they're just posting out to Google Analytics. It could be a compromised third party. The idea is because these policies for a modern website to work with a bunch of integrations and everything else, because of that case, there's always going to be a way for the attacker to exfiltrate the data, or almost always, to be fair, no matter what. And that's aside from all the operational stuff of like, how do you find all these things and how do you do it? So there's 2 points to CSP. One is that it's really hard to do. And 2 is that when you do it, it's probably going to be ineffective. The second part of this is sub-resource integrity. And sub-resource integrity is like a way more straightforward thing than CSP. The basic idea here is we want to make sure the file that's loading in the browser is what we expect it to be, that it hasn't changed without us knowing about it. So this kind of attempts to solve that first problem with CSP, that malicious content could still be loaded. The idea being that if you check the script and then you fingerprint it, then it can't change and you know it's good. And the browser will load a known good copy of the script. This is, by the way, where the assuring integrity language came from in DSS, but that doesn't mean you have to use sub-resource integrity to assure the integrity of something. You can use a bunch of different techniques to assure the integrity of a script, but I wanted you to know like kind of the evolutionary beginnings of that term. I'll just go back to this real fast. Sorry, I keep hopping around, but you can see right here, I think it's an important point. You can see right here that integrity is a requirement, part of the requirement. And there's a bunch of ways to satisfy it with different controls, SRI being one of them, but also things like monitoring the web page. So I'm just calling out that the Security Council themselves have said, you do not have to do SRI to satisfy integrity. I think that was kind of a disservice to put those words so close together in the standard. So I like to really hammer that point home. So SRI works by fingerprinting files and then forcing the web browser forces the enforcement of those fingerprints. If the fingerprints don't match, the tool, the script will not be loaded, or other resources if you're really getting crazy with it, like images or CSS files. But the idea is that if fingerprints don't match, the file doesn't get loaded. The concept's pretty simple. The problems with this are, there is a security issue with this, meaning that if you hash, well, actually, I'll go through it in order. Scripts are often dynamically generated. So what I mean by that is when you go to a given web page and there are marketing integrations or there are really any kind of third-party integration, you are relying on that other server on the other end to give the browser that file. So I'll just pull this up here just so you can see it. On this demo website I have around, you can see that there's a lot of different third-party integrations here. Now, every time my browser requests these files, the server on the other side can, and probably does, change the contents of the file based on who I am. So like I'm just highlighting Facebook Connect here. And as you can see, it's got all this stuff in it. The reason these things are in here is because this is all unique to me, Matt McGurk, as a person visiting this website, so they can track me. So the point I'm trying to get at here is how can you generate a hash? How can you fingerprint a file that is going to change based on the behavior of the user, or even just on every page view? Web applications often use something called cache busting, where you just kind of put some junk in the file to force the browser to load the most recent version of the file. So the point is, from a fingerprinting cryptographic signature kind of standpoint, it's going to be impossible to keep up with a dynamically generated file. It's just always going to break. And it's important to note that when a sub-resource integrity check fails, the browser just refuses to load the file. So if you think about this in the context of your own first-party code, like your own software, the front end of your web application, if the hashes get broken, that stops loading, which is kind of a problem if you want your web application to work. Third parties must provide. So you got to work with your outside vendors to get known acceptable, known safe and secure copies of their code. So you can imagine how that might be tricky with something like Google or something like Facebook. You'd have to coordinate with them for releases of their software. You would either have to trust their development lifecycle to be secure, or you would have to do that vetting yourself in-house, like do the code review and make sure you're comfortable with it. So that's a prerequisite as well. And then like most straightforward here is that in a supply chain sense, meaning that if their scripts load other scripts, SRI isn't saying anything about the validity of those other files. So if my fingerprinted, code reviewed, known good copy of Google Analytics pulls in another script file, another service, all SRI is doing is saying, yeah, that address that it's going to request something from is valid. Not not that the address not that the file itself is okay or anything else about it. So this is like a really glaring security hole or security problem with SRI that has always irked me personally. So I know I've been pretty negative on these two things, but I think it's important to note those as you consider going into a CSP SRI project, because more frequently than not, what I see when folks endeavor or go about the beginnings of those projects is it's kind of like, all right, no problem. We'll get these things in the web application and then we'll be done with all of these items. However, it can be much more upfront work than might be initially anticipated. And then two, there's stuff I haven't even really touched on here. Like, for instance, with alerting and reporting in general, CSP and SRI don't have any native like log collection mechanism. CSP will let you configure where logs should go, but it doesn't say anything about what's going to happen after the browser sends that data out. So literally you say, here's a location you should send error messages to, and then it's up to you to solutionize how to collect those and then report on them and everything else. Alerting, reporting, the general compliance work of like producing evidence, all those other things are simply absent from CSP. And then last and not least, just be careful if you implement CSP that nobody CSP has a feature called report only, where you can set all these rules and do all this stuff and then say, don't enforce anything in here. Just report on errors, kind of put it in test mode. And for a long time, this would let you, like if you do an outside scan of your site, and Scorecard and other tools will do this and say, all right, we scanned your site, we found CSP, you're good. But if the CSP is in report only mode, then it's kind of like you got a checkbox for doing it, but it's not going to do anything against a security problem. It's just going to be in report only mode. So make sure that if you're doing it, the policies don't end up getting so leaky, so poorly configured that somebody fell back to report only and it's not really doing anything. So with all that said, I want to talk about what would be a usable eSkimming solution as opposed to just a compliant one, right? You may have heard the term like compliance versus security, which is kind of some of the themes I touched on before. Like you can be compliant and not actually make anything more secure. What I'm trying to get at here is you could make your site compliant in a way that's completely unusable for your organization and for your assessors and stuff. So I've broken this out into a few points. The first one is that a usable solution should do the compliance stuff. So this is kind of a joke, obviously, but I've talked for a long time about authorize and justify and do that and assure the integrity of and monitor HTTP headers. I'll touch on it a little bit more as we go, but suffice it to say, you need to follow the rules and the tool needs to do the compliance stuff. More importantly, I think, is that it should have minimum technical effort to implement. It should be operationally efficient, meaning that the team is going to keep working with it to actually keep the site secure and compliant. Shouldn't have to spend a huge amount of time doing that. And then it should be easy to produce evidence and the artifacts related to the evidence so that you can prove you're doing all that stuff. So these items, I think, are really what gets ignored by what I sometimes call in myself the engineer brain, right? Engineer brain sees a problem. Let's find a bunch of mechanisms to fix that problem and then we're good. Well, that's all true, but you do also need to consider how are you going to deploy that solution to the problem? How are people actually going to use it? And then how are you going to prove you're using it effectively? So in terms of minimal technical effort to implement, I think some things people should ask themselves, and like I said, the prior slide said, this is kind of a checklist. So if you're going through the work of figuring this out, I would urge you to ask yourself these questions. So is the solution agent-based, agentless, or hybrid? So what I mean by this is our space here, web application, client-side security, security solutions for the code inside web pages, has kind of fallen into these three categories where I'll start with agentless because it's kind of easiest. This is a scan. This is someone who will scan your website or a tool that'll scan your website from the outside in, crawl it just like a web crawler for generations literally has at this point, and then gather the information it needs to generate to show you a dashboard basically and help you do the compliance tasks. That's one way to do it. Agent-based solutions involve an installation into the web application. This varies. So if you're talking to like a CDN or WAF provider, you might have to change something about your network configuration and then something ends up in your web pages. If you're talking to a solution like Source Defense, you would see an addition of some JavaScript to your web pages. Basically, there's a bunch of ways to get there, but the point is something that is inside the web page as it executes. And a hybrid solution would take advantage of both approaches. Source Defense is a hybrid solution where we can do either or both to help with that. As you consider also is, can the solution be self-onboarded? So how much does your team need to work with the vendor in order to get it up and running? I know, as in my work as a developer, I really like to be autonomous. And so the more work that the development team can do without speaking to a vendor is valuable, in my opinion. What teams need to be involved in the implementation? So in an agent-based solution, it's pretty much going to be application development. You're going to ask a developer to copy and paste some code. For a CDN-based solution or something else like that, your infrastructure and network teams might get involved. They might have to, well, in some cases, you might have to change the content delivery network altogether, which can be kind of a huge bummer. And then last but not least, identity and account management. So what I mean by this is if you're going to go with an agentless solution, something that scans, and your payment page is behind a login, somebody needs to give the vendor that login. They need to figure out how to scan the site. So that's one consideration for those, what teams. And then initial effort versus ongoing effort. So it's going to be an initial lift to get a solution up and running, but like also how much is it going to be over the years? And I know that there's also like an operational part of this, justifying your scripts, assuring the integrity. That's not quite what I mean here. What I mean is your development team going to have to make changes to how they deploy your software, your website in the future? Are they going to have to add a step to what's called the CI/CD, the continuous integration, continuous deployment pipeline? Because that can be a huge bummer. You don't really want to add, well, nobody wants to add more work to the developers' plates because it's so valuable, the time they have. So those are considerations for implementation. Number 3 here, produce evidence and artifacts. So something that's kind of missed with or often overlooked, I should say, with a DIY solution is how do you prove that you did this? A lot of times when we do projects internally in any kind of business sense, you owe somebody proof that it was a good idea and that it was cost efficient or whatever. But in this particular case, you literally have to have an evidence kind of document to give to a qualified security assessor to attach to your SAQ or ROC. You literally need evidence and artifacts. So are you going to generate that yourself? How are you going to gather it along the way? How much time is that task going to take? And will your assessor or the other interested party, depending on what kind of business you're in, accept that evidence and understand it? So are you kind of putting it in a format that, you could write down on the back of a cocktail napkin where all your scripts are, but that's not going to be a very easy to provide or perhaps reputable. And the point being is you want to give them the stuff they expect and that it's an easy to digest format. And then operational efficiency, I think, should be like almost, I put it in here last just so it gets the most attention, but I think is probably the core of this. As you look at a market, like if you're out in the market looking for a PCI DSS 643 and 1161 solution, I really think this should be top of the list. So something to consider is who's actually going to use the tool. I think that, people kind of this is what I see out in the world. You get a report back from an assessor saying, hey, you have this gap and you need to deal with it. They say, great, let's go get a solution for it. And then kind of along the way, you do the work of figuring out, okay, this is going to live in the governance part of my organization, or this is going to live in app dev, or this is going to do in security operations or DevSecOps or so on and so forth. So I think it's very valuable, in my opinion, to figure that out from the jump, or at least begin that conversation as you either specify your own solution or as you do vendor selection. And then think about how are these people going to collaborate with each other? Because it's almost always a collaboration. Does the tool give you an easy way to let multiple folks work in it and handle their different areas of responsibility? How will training happen? So this gets overlooked all the time, in my opinion. You're not just going to get a tool and then magically it starts working and everybody knows how to use it. What's the onboarding like from the vendor, but what's also the use of the tool like in terms of, is it self-sufficient on its own? It's kind of like a counterpart to self-onboarding. Can you give someone else at your org who has a basic introduction to the problem and what you're trying to do? Can you give that person access to the tool or the solution, and can they get up and running on their own? Or do you need to become a trainer, or do you need to build a training part into your process and documentation? I think that's a really important part of this, especially as we're still in this first year of these requirements being mandatory, to consider in terms of the overall operational cost. And then what about the ongoing support from business and like the primary stakeholder? So what I mean by this is if you're looking at it as a project in like any other project in your portfolio, what's it going to take year after year to keep this budget line getting approved and make sure that it's considered a successful project and it doesn't end up as one of those that's just like on the shelf and all that stuff? Is the vendor used to working with your kind of org, whether it's very, very large, like a payment brand, or relatively small, like a individual e-commerce shop? Are you signing up to get a whole platform? What I mean by this is, are you getting a point solution? The second bullet here at the bottom. Are you getting a point solution that solves 643 and 1161? Or are you signing up to like also get a secondary WAF because it happens to solve this problem? So, how big of a solution are you buying, or how much does it cover? And then does the solution help you justify its own cost? Or are you going to be doing that on your own shoulders? So these last things are a little more like, managerial portfolio management kind of stuff. But I've started to see, as this space matures and kind of solidifies, people thinking about these parts of solution selection. And again, all this stuff, if you're, I guess what a lot of this sums up as, like I said, I spent a lot of time being a web dev, web application developer. And if you came to me with any problem, we would have said, no problem. We can do that. With enough time and thinking, we can solve pretty much any problem that you throw at us. And that's probably true. Devs are really smart, and usually we're pretty good at our jobs and everything else. But the considerations that are lacking from that approach, that engineer brain I talked about, is all of the collateral that comes along with solving the problem. How are other people going to use it? Who's going to maintain it? How are we going to prove it was a good idea? How are we going to prove to other people that it does all these things on this screen? So the fundamental idea is, is the way you're going to approach this problem going to be compliant, or is it going to be usable, or is it hopefully going to be both? And so that's my advice. I do briefly want to show you how we approach this problem, because I think we have a pretty good way of doing it. Source Defense is like I said, we are a vendor in this space. We provide a hybrid solution, meaning that our solution, I would say, relies very heavily on being an agent in the browser. But in cases where it's necessary and useful, we can scan a site externally. What you're seeing on my browser screen right now is the Source Defense PCI DSS dashboard. So like I said, we were founded to be an anti-eSkimming company, if you will. We've been doing that for a very long time. And as a result, we can build solutions and workflows like the one you see on the screen to make compliance very easy with us. We solve the underlying problem, so proving that we make your website compliant is very easy as well. Our deployment, I'll show it here just so you guys can see it on that headphone site. We are deployed as a JavaScript integration. To boil all of the technicals out of this completely, our team would give your team a text file that contains lines just like this one. They would take those lines and copy and paste them into your application, and then they'd be done. There is no further network configuration. You don't have to give us any kind of credentials. We don't need access to any part of your development environments, nothing else. This code goes in and the rest of it works. We also, by the way, I would mention, we don't collect any personally identifiable information or IP addresses. The only thing we store is about the behavior of scripts and the things necessary to provide this compliance functionality, but no PII, nothing else. We're also PCI DSS compliant ourselves. We have an AOC through IBM, and we carry an ISO 27001 cert, just so you guys know. So I think we're pretty well buttoned up there as well. A day in the life of our platform might look like I receive an alert saying a script has a new behavior. I can hop into this interface and see all the scripts with new behaviors. And this might indicate a problem with the integrity of these scripts. And so in contrast with Subresource integrity, where the file may have changed and then it got turned off, Source Defense will say, here's exactly what behaviors changed in this script. I can analyze those behaviors, and if I'm comfortable with them, I can go ahead and acknowledge them. And that trains the system that everything's hunky-dory. I can move on with my day, and I can also prove at a later date that the integrity of the script was assured in a DSS sense. The other thing I wanted to point out while we're here is that Source Defense is an active code control. We're an active security tool. So as we're running inside the web page, we're not just going to assure the integrity. We're going to guarantee the integrity or enforce the integrity over those scripts. So you can see here for this tool, Heap Analytics platform, Source Defense is redacting any card information if that script tries to access it. So if one day Heap gets misconfigured and starts vacuuming up every piece of user data on the page, or it's involved in a supply chain attack, like it adds some other malicious script to the page, we're going to prevent it from getting those card numbers. And we're going to do that without interrupting the normal operations of the script. So that's really important. We're a granular security solution. So unlike CSP and SRI, or CSP in specific, we're not just concerned about where the file's coming from or the hash of the file. We're concerned about the behaviors of the file and limiting those behaviors to the least necessary set of permissions. What this means is that in the long run, we're super lean in terms of alerting. We're only going to alert you when something new and interesting happens, not just when the file changes. And in terms of effectiveness, we're going to block the negative behavior, but not interfere with the behavior, the beneficial behavior of the scripts, which is fundamentally different from CSP and SRI. The other idea here, or the other, I just want to show you a couple other things because I think they're cool. Inventories happen handled automatically. So you can see here a visualization of an inventory on a particular payment page where we're deployed. We classify automatically all the script files into their services. So you can see here, like the YouTube service. I don't have to care about what files are involved in showing a YouTube player on my web pages. I just know that the YouTube player, let's call it service, is there. I can also see that supply chain visualized. So if I need to answer the question for an assessor, why is the Zoom info script service running on your site? I can tell you that it's there because of the YouTube image preview script. This was loaded by that, which was loaded in turn by the YouTube player, which in turn was loaded by a marketing tool called Matomo. So that little micro story is way easier to tell with a tool like ours than with something else. You can also see lots of stuff about the behavior of scripts, including in aggregate, and you can export these if you like. So all of them coming back to the themes of like, how usable is this? Well, with one click, now I'm into every script that's accessing PII, and I could export it right from here, maybe forward it over to our attorneys to make sure that they're cool with this level of exposure to these third-party vendors. Or maybe they can start to enforce the SLA that you have with HubSpot or whoever about what data is being accessed if you're not having us automatically redact it for you. We also serve as a place to grab all the evidence that you need to satisfy your reporting requirements. So with a single click here, I can get all of the PCI relevant reports out of this dashboard. I would say that we've here, Source Defense as an org, have worked with, I want to say about like 80% of the English-speaking QSA firms in the world to different degrees, basically just doing education or sometimes more closely knit. But the point I'm trying to get to is, with generally speaking, whoever your QSA is, they'll have heard of Source Defense and they'll be happy to receive reports from us. This should be the only mouse click you need to take in order to make sure the site is compliant. So in a few mouse clicks there, I hope I've been able to show you, how we handle inventory, basically how we satisfy all those controls in that table, and also wrap it up into a usable package that should satisfy all the operational requirements. And last but not least, we'll give you a tour of all this stuff in your own dashboard with your own data, so you don't have to train anybody, which I think is pretty valuable. I'm going to wrap it up there, and I'm going to bring it back to here. If you want to get your own instance of Source Defense, you want to see how we work on your own site, we can kick off a scan. You don't have to deploy anything. You just hit that URL there or scan the QR code, sourcedefense.com/free-PCI. That'll set up, that'll kick off the process to get you access to your own demo dashboard based on a scan of your own site. If there are any questions, I'm happy to take them through the chat. Also, I'm Matthew@sourcedefense.com if you want to email me directly. And I'll just hang out here for a second and see if we get any Q&A. Okay, so I see this is a standard theme we get on these calls. So given the changes back in, I'm paraphrasing here, the question, there were some changes to the SAQA back in, I believe it was March of this year, right before the requirements went to required from best practice. And so the question is, it seems like I have to implement CSP and SRI. I use an SAQA. It seems like I have to implement CSP and SRI to be compliant, or I don't have to do this at all. Can you explain more about that? Okay, sure. So it's a little bit of or it's a lot of a misconception that the council removed these requirements or weakened them or something. There's a document called the Self-Attestation Questionnaire, version A. And that's what an organization would fill out to say that they're compliant with PCI DSS. The SAQA is like the most lightweight version of it. If you have like the least amount of credit card exposure in your org, then you can use an SAQA. And what the Security Council did was change the language in there to say that if you want to use this type of questionnaire, you have to prove that your site is not susceptible, that's the language, not susceptible to script-based attacks, or you have to do what's in 643 and 1161 if you can't prove that. So it's like a really odd choice they made there to say, because, well, first of all, before 643 and 1161, you have to do on your payment pages or a page into which a payment form is embedded. SAQA says you have to make sure your site is not susceptible. So if you read that thing very closely, it seems like they broadened the scope, in my opinion. But sometimes this leads to the misconception of, oh, they got rid of these rules, at least for certain merchants, which is just not the case. You still have to make sure your sites are not susceptible to script-based attacks, and you have to provide evidence of that. And most of the QSAs with whom I've spoken have said, well, since there's no clear rules on how to prove something's not susceptible, we're just going to use 643 and 1161 anyway. So kind of they kicked up a lot of dust over this thing for no, well, I mean, there's reasons for it. But what I'm trying to say is that at the end of the day, you still have to do it, or you have to do something very like the rules. So I do not see any other questions here in the chat. So I think we're going to call it there. I want to thank everybody for their time and their attention today. If you have any follow-up questions, again, my name's Matt. I'm Matthew@sourcedevents.com. You can hit that URL right there and get some more information and your own dashboard. And once again, I hope you have a great day. Thanks so much.